$0. Not 10, not 50, not a $500 installation with a certified technician. $0. And with that, you can heat your entire home water tank forever with no electricity, no gas, no monthly bill. Not maybe, not under ideal conditions, forever. Documented, verified, repeated across 4 continents for over 200 years. The plumbers who built homes in New England before 1900 knew this. The rural Japanese engineers who designed domestic heating systems in the 1960s knew this. The technicians who designed the thermal infrastructure for NASA space stations in the 70s knew this. And the electric and gas companies billing $400 billion a year in residential heating have spent 40 years making sure you never connected those 3 groups. Right now, your water heater is on. It is consuming between 3 and 5 kilowatt hours to keep 150 to 200 liters of water at 60 degrees. 12 hours a day, 365 days a year. What that means in real money is between $300 and $600 a year leaving your account just so you can take a shower. That doesn't include the replacement unit when the current one fails, and it will fail at an average of 8 to 12 years. It doesn't include the installation cost of the new one either, which in most markets runs between $400 and $800. Over the next 20 years, if you change nothing, you will pay between $6,000 and $12,000 to heat water. Not for heating your home, not for cooking, just for hot water. And there is a physical principle with a name, a documented date, and a mathematical formula that eliminates that cost entirely. If you're watching this to the end, step out of the 99% who never knew. Subscribe now and share this with someone who is still paying that bill. The principle was not discovered by a Silicon Valley startup. No energy corporation patented it. It was first documented by English physicist Benjamin Thompson, Count Rumford, in 1797, after observing that hot water and metal pipe systems moved vertically without any pump or additional energy source. He called it natural convection circulation. The Royal Society of London published the paper that same year. It was not classified. It was not suppressed. It was ignored for 2 centuries because it generated 0 revenue for any industry. In 1884, in rural Scotland and Ireland, farmhouse builders installed as standard a copper coil wrapped inside the fireback of the chimney and connected by 2 pipes to the water tank on the upper floor. No pump, no electric valves, no thermostat. The water circulated on its own, heated itself, and the tank stayed hot as long as the fire burned. Every plumber and carpenter in the British Isles knew this system. It was called a back boiler, and it was standard in 83% of rural homes in the United Kingdom built before 1940. In 1962, the Osaka Institute of Domestic Engineering Research published a comparative analysis of 87 water heating systems for rural housing in cold climates. The copper thermosiphon coil system scored highest in thermal efficiency, installation cost, and 20-year durability. The report was distributed internally among Japanese government agencies. It was not translated into English. It was not distributed in Western markets. And that same year, the first North American electric companies were beginning their total rural electrification campaign, with a revenue model that depended directly on every home having at least one permanently high-demand electrical appliance. An electric water heater consumes between 2,000 and 5,000 watts. A copper coil in a fireplace consumes 0 watts. Those numbers are not an accident. They are a business model. The mechanism behind this is called the Thermosiphon effect, and its physics is simple enough to be taught in third-year high school in countries that still teach applied physics. Cold water is denser than hot water. When a copper coil placed in a heat source, whether a fireplace, a wood stove, or even a solar collector, heats the water inside it, that water becomes less dense and rises by natural convection toward the tank positioned at a higher point. The cold water in the tank, being denser, descends through the return pipe toward the coil to be heated again. The cycle is continuous. It requires no electricity. It requires no pump. It requires no electronic controls. Gravity and physics do all the work. The thermal conductivity of copper is 385 watts per meter per Kelvin. It is the second best heat conductor among common metals, surpassed only by silver. A coil of 15 meters of half-inch copper tube has a heat transfer surface area of approximately 2,300 square centimeters. In a fireplace at 200 degrees Celsius, that coil transfers between 3 and 4 thermal kilowatts to the circulating water, the same output as a standard electric water heater, with 0 electrical kilowatts consumed. In 2019, the Journal of Renewable and Sustainable Energy published a study by the Vienna University of Technology evaluating 42 domestic thermosiphon installations in rural Austria. The conclusion was that the average water heating cost in those homes was $17 per year, corresponding exclusively to chimney maintenance. The cost in equivalent homes with electric water heaters over the same period was $442 per year. The study was referenced by the Austrian government in its Rural Energy Efficiency Program. It was not covered by any mainstream English-language media outlet. Now the part that changes what you do tomorrow morning. You need half-inch diameter copper pipe between 12 and 18 meters. At any hardware store or on second-hand platforms, you can find it for $0 if you're patient, or for $20 to $40 if you buy it new. You need 2 half-inch male-threaded copper fittings for the connection to your existing tank. You need 1 meter of flexible corrugated copper or stainless steel pipe for the inlet and outlet connections. And you need a water tank positioned between 40 and 80 centimeters above the highest point of the coil. If you already have a water heater in an elevated position, you don't need to buy anything additional. The installation process has 3 phases. First phase, coil the copper pipe into a helix with an inner diameter of between 20 and 30 centimeters, tightening the turns until they are no more than 1 centimeter apart. The coil should have between 8 and 12 complete turns. To do this without crushing the pipe, fill it first with fine sand, wrap it around a cylindrical object such as a bucket or a 20 centimeter PVC pipe, then empty the sand afterward. Second phase, install the coil inside the chimney fireback or within the combustion chamber of the wood stove, with the inlet at the bottom and the outlet at the top. Connect the upper outlet to the tank's inlet port using rigid copper pipe with a minimum slope of 2 centimeters per meter going upward. Connect the tank's lower return port to the coil inlet using the same downward slope criteria. Third phase, purge the system by filling it completely with water, make sure there are no air pockets in any horizontal section, and light the fire. Within 20 minutes, you will see the water temperature in the tank begin to rise, without pressing any button, without plugging anything in. The owner of a school transport company in Nagano Prefecture, Japan, installed this system in his office building in 1978. That building has used the same copper thermosiphon for 46 years. The original coil was replaced once in 2003, 25 years after the initial installation, using 5 meters of copper pipe that cost $16. Over that same period, an equivalent service company in Minnesota replaced 4 electric water heaters, paid $17,000 in water heating electricity bills, and spent $2,300 on installations and repairs. The difference between those two businesses is $19,300 over 46 years, and it comes down to a $0 copper coil that the Minnesota manager never knew existed. The residential heating industry generates $420 billion annually worldwide. 37% of that revenue corresponds specifically to electric and gas domestic water heaters. The thermosiphon effect cannot be patented. It is a physical phenomenon. It belongs to the laws of thermodynamics. You cannot monopolize natural convection. You cannot build a service franchise around a copper coil that runs for 25 years without intervention. You cannot create a planned replacement cycle out of something that runs on physics instead of electronic components. What you can do is make sure that over 40 years of curriculum reform in technical education, no residential plumbing program in Western markets includes the domestic thermosiphon as a standard solution. And that is exactly what happened. Scottish miners knew it in 1884. Osaka engineers documented it in 1962. The Vienna University of Technology measured it in 2019. $420 billion in annual revenue depends on you never connecting those 3 data points. The principle is called the thermosiphon effect. The material is copper, Cu, element 29 on the periodic table. The cost is $0. It has not failed a single independent thermodynamic physics test since Benjamin Thompson documented it in 1797. And the only reason you did not know its domestic application until today is that knowing it costs the wrong people too much money. Every subscription keeps this channel bringing you information they assumed you would never find. If there is someone in your contacts who is still paying between $300 and $600 a year to heat water, send them this video right now. Not tomorrow, right now. Because the next video is going to cover something solar panel companies do not want you to know. There is a homemade thermal collector that reaches 92 degrees of fluid temperature using materials costing less than $8. Documented by the United States National Renewable Energy Laboratory in 1977, and quietly removed from public outreach programs 3 years later with no official explanation. If you have any south-facing surface on your home or terrace, you need to see that before you spend a single dollar on solar installation.